everyone, welcome to our virtual collaborative discussion of Chapter 5.
Hi, my name is Norishin. My student ID is 19001236 and I'm from Chemical Engineering, Thermodynamics Group 3.
Hello, my name is Aiman Ikmal with ID number 19001651. I'm from Group 3 Thermodynamics.
Hi, I'm Sara Safiah, student ID 20001477 from Group 3 Thermodynamics.
Hi, I'm Khairina, Binti, Khairul, Anuar, 19001294 from Group 3 of Thermodynamics.
Hi, I'm Azalia Binti Abdullah with ID number 19001358 from Group 3 of Chemical Engineering Thermodynamics. Our group is going to be presenting on mixing chamber. Hello, Blast!
Okay, this video consists of 4 parts. The first part is the general schematic diagram of mixing chamber. The second one is the functions of mixing chamber. Then we have the examples of its application in real life. And then the last one is the question and also its solution. So this is a general schematic diagram of mixing chamber where it usually has 2 feed streams and also 1 output stream. Then we have the functions of mixing chamber. So mixing chamber is actually a type of well-insulated steady flow engineering device that properly mixes 2 or more streams of fluid to cause a temperature change. And it is also highly dependent on the mass flow of the feed streams in comparison to each other. Next is the examples of its application in real life. The first one is the open feed water heater. So open feed water heater is actually a mixing chamber where the stream extracted from the turbine mixes with the feed water exiting the pump. Hence, the mixture leaves the heater as saturated liquid at the heater pressure. So this is an example of diagram of open feed water heater. Next, we have T-elbow of ordinary showers. So it is functioning by balancing the temperature of 2 streams of water consists of hot and cold water stream. So this is the diagram of the elbow of ordinary showers. Next, we have the gas mixing chamber. So the function is mixing the gases at different temperature respectively and also consequently equalizing the temperature of the already mixed gas mixture. The diagram.
Alright, so after hearing the explanation from Khairina, let's do some tutorial questions on mixing chamber. It's given that liquid water at 300 kPa and 20 degrees Celsius is heated in a chamber by mixing it with superheated steam at 300 kPa and 300 degrees Celsius. The liquid water enters the chamber at a rate of 1.8 kg per second. If the mixture leaves the mixing chamber at 300 kPa and 60 degrees Celsius, determine the mass flow rate of the superheated steam required. So we convert all the information from the question into this diagram here. For interflow number 1, we have liquid water at 300 kPa and 20 degrees Celsius. For interflow number 2, we have superheated steam at 300 kPa and 300 degrees Celsius. The liquid water and superheated steam are mixed in the mixing chamber and the product is released at 300 kPa and 60 degrees Celsius. The liquid water enters the mixing chamber at a flow rate of 1.8 kg per second. Before we can move into the calculation, we will need to determine the value of H from the property table. At 300 kPa, the temperature of liquid water and product is lower than 133.52 degrees Celsius. Based on table A4, H1 equals to 83.915 kJ per kilogram and H3 equals to 251.18 kJ per kilogram. For superheated steam, table A6 is referred and H2 equals to 3069.6 kJ per kilogram. Using the mass balance equation, we know that M1 plus M2 equals to M3. From the first law of thermodynamics, we know that energy input is equal to energy output when system is at steady state. Assuming that the system is well insulated, the state of heat transfer is 0 and work is 0. The kinetic energy difference and potential energy difference are also assumed to be 0. By substituting the mass balance equation into the energy balance equation, we get that M1H1 plus M2H2 equals to M3H3. Now, we substitute all the information we have into this equation. The final value for M2 is 0.107 kg per second. So, this is the end of the virtual collaborative discussion from Group 10. Hope you learned something new, and if you like this video, remember to give us a like and share this video around. Thank you and stay safe.